Hey everybody, so in this video we're still going to be talking about sum and difference identities. So the problem tells us that tangent of alpha is -4/3, alpha lies in quadrant 2, and cosine of beta is 7/8 and beta lies in quadrant 1. So you'll notice over here on the right I have alpha lying in quadrant 2 and then right below it beta lying in quadrant 1. So it says that tangent is -4/3. Well, we know tangent is the opposite over the adjacent. So here, if I label these sides, so if I come over here to alpha, the opposite leg from alpha is going to be 4, and then the adjacent leg is going to be 3. Now, the ratio itself is negative. So in quadrant 2, my x values are negative. So I want to make sure that this 3 is negative. So here I have a 3, 4, 5 right triangle. You can always find the hypotenuse by doing Pythagorean's theorem, but we know that that solution is going to be 5, so we'll put that here. Cosine is 7/8, so we'll come down here to beta. Cosine is the adjacent over the hypotenuse. So if the adjacent leg to beta is going to be 7 and my hypotenuse is going to be 8. Now we need to find our height here. So what I'll do is I can use Pythagorean's theorem. So the square root of 8 squared minus 7 squared is going to give me the square root of 15. So here I have the square root of 15. That's going to be the value of this leg here. So it says find sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha plus beta. Whenever you're doing these sum and difference identities, all you're really doing is just plugging in ratios. So here it says that find sine of alpha. Okay, where if I come up to alpha here, sine is the opposite over the hypotenuse. So this would be 4/5, and we're going to multiply that by cosine of beta. Well, cosine of beta was given to us in the problem, and that's 7/8. And then we're going to add to that cosine of alpha. So I come up to alpha. Cosine is the adjacent over the hypotenuse. So that's -3/5. And sine of beta. Sine of beta is going to be the opposite over the hypotenuse. So that's the square root of 15/8. So here I will multiply these together. So 4 times 7 is 28. 5 times 8 is 40, and then here I will add -3 times the square root of 15 all over 5 times 8, which is 40. So here, this is going to be a rather strange looking fraction. So because my denominators are the same, I can write this as one fraction, and that will be 28 minus 3 times the square root of 15, and this will all be over 40. So I'm going to move this down just a bit so that we have a little bit of separation here. There we go. So that's going to be sine of alpha plus beta. Now it says do cosine of alpha plus beta. So here we'll have to write pretty small to fit all this in. So cosine of alpha is going to be -3/5. We just found that. So we'll do that right down here. Let's say -3/5 times cosine of beta, which is 7/8, plus sine of alpha, which would be 4/5, times sine of beta, which is going to be root 15/8. So here I can multiply it straight across, and I'm going to get -21/40 plus 4 root 15 all over 40. So again, my denominators are the same, so I can write this as one fraction. So I have -21 plus 4 times the square root of 15, and this will all be over 40. Now, tangent here, you're going to have a lot because you have fractions in the numerator and you'll have fractions in the denominator. So knowing what my solutions are with sine and cosine, I'm going to erase to give myself a little bit more room. So if you still need to write this down, you can go ahead and pause the video now. So it says tangent of alpha plus beta. So tangent of alpha is going to be the opposite over the adjacent. So if I look at alpha, the opposite over the adjacent is going to be negative 4/3. So here I would say negative 4/3. Now remember, it really doesn't matter which number is negative, the 4 or the 3, when you're writing the ratio. All that really matters is that the ratio itself, the fraction, is negative. Then I have tangent of beta, which would be the opposite over the adjacent. So this will be plus the opposite over the adjacent, which is the square root of 15/7. And this will all be over 1 minus tangent of alpha, which is going to be negative 4/3, times tangent of beta, which we've already found to be the square root of 15/7. So here, let's move this over to the left so that we can get a better look at it when we start simplifying. So here, you'll want to add these two fractions together. So remember that you can't add fractions unless you have common denominators. So this fraction will need to be multiplied by 7/7, while this fraction will need to be multiplied by 3/3. So here I have negative 28 over 21 plus 3 times the square root of 15, and that will all be over 21 as well. So you see how I have this negative here times this negative? That's going to make it a positive. So I can go ahead and say 1 plus. So that's going to be 4 root 15 all over 21. Now again, you have uncommon denominators in your denominator. So really, you'll need to multiply this now by 21 over 21. So in our numerator now, we can write this as one fraction. This is going to be negative 28 plus 3 root 15. This will all be over 21, and this will be divided by 21 plus 4 root 15, and that will all be over 21 as well. Now here you have what's called a nested fraction. So we have a fraction in the numerator and a fraction in the denominator. We don't really want this because there is a little bit of room to simplify. And what we'll do is we'll rewrite this fraction over here in red using traditional notation. So we'll have negative 28 plus 3 root 15. This will all be over 21, and we're going to multiply by the reciprocal of the denominator. So if we wrote this out traditionally, it would be negative 28 plus 3 root 15 all over 21 divided by 21 plus 4 root 15 all over 21. Since we know that when we divide fractions, we have to multiply by the reciprocal, we'll go ahead and do that step now. So we'll take whatever the denominator is and we'll flip it. So this is going to be 21 all over 21 plus 4 root 15. So here, my 21s cancel out, and I'm left with negative 28 plus 3 root 15, and this will all be over 21 plus 4 root 15. Now, traditionally, you can pretty much stop here. That would depend on the preference of your teacher. So if your teacher wants you to rationalize, then you'll have to multiply by the conjugate of your denominator. So you'll have to multiply by 21 minus 4 root 15. So that way you can eliminate your radicals from your denominator. If your teacher's fine with leaving it as a reduced fraction once you divide it, then this will suffice here as both are numerically equivalent. All right? That's going to be all for this example. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.